In Python, every value is an object and every object should belong to any one class. And that class is called as data type or type. So what is this confusion? See, you take any value starting from number, string, or any other type of value. It can be either simple or complicated value. Every value is an object internally in Python language. For example, let's say we have a value called 100, otherwise at least 10. So this particular value is an object. Not only 10, any other number, it can be integer number or floating point number, it is absolutely an object in Python. For example, we have some negative value, something like this. Or you might be having a floating point number, something like this. So any number, any string, all these values are objects internally in memory. So what is an object exactly? You can understand the object as a memory location in RAM to store a particular value. It can be either one value or multiple values. If it is one value, you have to call it as primitive value. For example, all these numbers are primitive values. And even strings also primitive values in Python. So any string is a primitive value in Python. And in the same way, we have non-primitive values. That means multiple values in the same object. For example, you would like to store name of the person and his age. Like this, multiple values in the same object. So this type of objects are called as non-primitive values. That means multiple values in the same object. So like this, every value is an object. For example, 10 is an object, minus 30, every value is an object in Python. So if it is an object, every object should belong to any one class. For example, the object called 10 should belong to any one class. That is, it belongs to int class. And in the same way, this negative value, that is minus 10, also belongs to int class. This floating point value 4.34 belongs to float class. This hello, which is the string value, belongs to the class called string, that is str. And in the similar way, the values called true or false belongs to bool class. And we will create this type of classes for non-primitive values in further lectures. So for time being, focus on primitive values: int, float, complex, str, bool. These are the classes in Python which are meant for storing the primitive values. That means single value. For example, in your program, whenever you just write any number, for example, something like this, it is absolutely treated as an object. So it gets stored in the memory as an object. We will understand more about classes and objects in further sections, so don't get confused as of now. So for time being, you can call this 10 as a value or as an object. It is an object belongs to which class? That is int class. So the first step that happens internally is it creates an object with this value called 10, and that object reference will be supplied as argument for this print function, so that this print function accesses the same object and prints the same in the output. So it belongs to which class? Int class. So every class is also called as type or data type. So if you use the words like value or object, it means the same. And in the similar way, type, data type, class, all these are same meaning. we have another type of value, that is floating point type of value, something like this. This belongs to another class called float class, meaning this 4.53 something, this is an object that gets stored in the memory, and that object belongs to which type or which class? That is float class. But how can you believe that? Where is the proof? See, there are two ways to prove that data type or class name. The first way is, you can say type. It is the predefined function. So if you supply an object to the same, it returns the corresponding class name. That means the data type name. So this object called 10 belongs to which class? That is int class. Okay, ignore this less than and greater than, it is just for syntax. But actual name of the class is int. So any kind of large or small values, or even positive or negative numbers, all these are int data type. That means all the numbers that don't have decimal point are called as int. But whenever the number has a decimal point and one or more digits after that, this will be called as floating point type, and its data type is float. Means the name of that class is float. So the type is a function that returns you the name of the class based on the object that you supply here. Similarly, we have the third data type, that is complex. Complex also means a normal number with an imaginary part. Generally, we will represent that imaginary part for representation of electricity supply, which also means approximate value. For example, if you say 3j, which means that this is called imaginary number or approximate number, so its data type is complex. But it doesn't mean multiple values, it is the single value only. So here complex means it is just having an imaginary part. You can also try writing the normal number, that is for example 10, plus the imaginary part. In this case also it is the complex data type. But in the real world usage, we don't use this complex data type except for representation of imaginary numbers such as current supply in electrical applications. For other than that, we don't use this complex data type. And similarly, we have str for string data type and bool, which is true or false. Of course, it is self-explanative. So if you write true or false, it belongs to bool data type or bool class, which means boolean. So boolean values are about decision making. Let's say for example, if something is profitable, you want to do that particular activity, otherwise not. So for representation of that yes or no type of values, we use this boolean type, that is true or false. Here, the true and false should begin with uppercase, that is T and F. The data type of true and false is bool, that is bool class. Alright, we have understood int, float, complex, bool, these data types. Similarly, we have string data type. So whenever you use the double quotes or single quotes, it is by default treated as a string. For example, something like this. Even though we are not writing as a string anywhere, it is by default treated as a string object. So it gets stored in the memory, and its data type means the class name is string. So the actual class name is str. Let's print the same here. No matter how many characters in these double quotes or single quotes, its data type is str always. Of course, we have learned a lot about strings and its manipulations in the previous section itself. So, the type function is one way to prove the data type or class name of the particular object. Is there any alternative way for the same? Yes, there is. So, instead of calling type, we can use the predefined function called isInstance. For example, I would like to check whether this object belongs to int class or not. So, we will call a function called isInstance. As the first argument, we have to supply the actual value, for example 10. And then as a second argument, we will supply the data type, that is name of the class called int. It should be completely in lowercase. So if this first argument, that is this particular object, belongs to this particular class, this isInstance function returns true, otherwise false. Presently, this object called 10 belongs to int class, right? So it returns true. Suppose if you say, hello is instance of type int. It is not, right? So it returns false. Like this, you can use any other data types like floating point, complex, or bool or string. For example, I would like to check whether this value is float data type or not. And also this is the complex data type. Here, J is the fixed character, always used for representation of complex numbers, that is imaginary part. You cannot use any other character other than J. So for all these cases, we have to get true, right? Yes, we are getting the same. This should be bool. So we are getting all true except this particular value, because this object called hello belongs to string data type but not to int data type. Alright. So in the real world applications also we use this type function to identify the data type of the particular variable. And in the same way, if you want to check whether the particular value belongs to particular class or not, you will use this isInstance. For example, you will write some code like, if isInstance returns true, then you want to execute some code, otherwise some other code. And moreover, in all these lines of code, instead of supplying the direct value to the type, you can also store the same in a variable, something like this, and supply the same here for the type function. It works in the same way. See, we are getting class int. Okay. So overall, we have understood about the basic or built-in data types in Python, that is int, float, complex, str, and bool. So the point that you should remember is that anytime when you write a number or string, those are by default objects. That is why you can say the Python is the object-oriented programming language. And in general, we can call the values as objects and data types as classes. And this is the cheat sheet for the same, for int, float, complex, bool, str, as well as the type function and isInstance function. So in further lectures of this section, we will understand more about data types, and also in later sections of the same course, we will understand how do you create our user-defined classes and objects based on those.